video, we are discussing about the combinational circuits. And the definition of the combinational circuits. Combinational circuit is a circuit in which we combine the different gates in the different circuits. For example, encoder, decoder, multiplexer and demultiplexer. Some of the characteristics of combinational circuits are following. The output of combinational circuit at any instant of time depends only on the levels present at input terminals. The combinational circuits do not use any memory. The previous state of input does not have any effect on the present state of the circuit. A combinational circuit can have an n number of inputs and m number of outputs. The block diagram of the combinational circuits. We are already discussed about n number of the inputs and m number of the outputs. The important combinational circuits are half adder, full adder, half subtractor, full subtractor, multiplexer, demultiplexer, decoder and encoder. In next slides, we are briefly discussing about these combinational circuits. And the first one is half adder. Half adder is a combinational logic circuit with two inputs and two outputs. The half adder circuit is designed to add two single bit binary numbers, that is A and B. It is the basic building block for addition of two single bit numbers. This circuit has two outputs, that is carry and sum. The outputs, that is carry and the sum, and the inputs are A and B. The half adder truth table is like this. We are taking the input variables A and B. These are the A and B, and the outputs are sum and carry. These are the four possible conditions. And full adder. Full adder is developed to overcome the drawback of half adder circuit. It can add two 1-bit numbers A and B and carry C. The full adder is the 3 input and 2 output combinational circuit. This is the circuit diagram of the full adder. A and B variables are the input and carry C in is the input terminal, and the outputs are sum and carry. We are join the OR gate inputs with AND gates. These are the truth table of full adder circuit. Half subtractor. Half subtractor is the combinational circuit with two inputs and two outputs. The outputs are difference and borrow. It produces the difference between the two binary bits at the input and also produce an output borrow. To indicate if one has been borrowed in the subtraction, A is called as minend bit and B is called as subtrahend bit. And this is the circuit diagram of the half subtractor. A and B are the input terminals and output sum means A plus B, and the second output is borrow. B is equal to complement of the first input A and the second input B. This is a truth table of the half subtractor. Inputs are A and B and outputs are difference and borrow. That's why these are the four possible combinations of the truth table. Full subtractor. The disadvantage of the half subtractor is overcome by full subtractor. The full subtractor is the combinational circuit with three inputs A, B and C and two outputs D and C complement. A is the minend, B is subtrahend, C is the borrow produced by the previous stage, D is the difference output and C bar is the borrow output. So the FullSubtractor circuit diagram is like this. A and A bar, B, C. These are the inputs of the half subtractor and the output of the difference, and C bar is the bar. So we have to write the truth table consider to the circuit diagram. Multiplexers. Multiplexer is a special type of combinational circuit. There are n data inputs and 1 output and m selective lines with 2m equal to n. It is a digital circuit which selects one of the n data input and rotates it to the output. The selection of one of the n inputs is done by the selected input depending on the digital code applied at the selected inputs. One out of n data sources is selected and transmitted to the single output Y. E is called the strobe or enable or input, which is useful for the cascading. It is generally an active load terminal. That means it will perform the required operations when it is low. This is the block diagram of the multiplexer. There are n number of data inputs and the enable input. These are the selective inputs and Y as output. Multiplexers come in multiple variations that are 2:1 multiplexer, 4:1 multiplexer, 16:1 multiplexer and 32:1 multiplexer and 2:1 multiplexer. The block diagram of the 2:1 multiplexer are like this. So 2 has represent the input data lines. That's why D0 and D1 is input lines, 1 enable pin and the selective pin, and the output is Y, taken as the Y. Enable pin is we have to set as low or high, and the selective pin is we need to set 0 and 1. X means don't care condition. Demultiplexer. A demultiplexer performs the reverse operation of a multiplexer. That is, it receives one input and distributes it over several outputs. It has only one input and output lines. M is selective input. At a time, only one output line is selected by the selected line, and the input is transmitted to the selected output line. A demultiplexer is equivalent to a single pole multiple way switch. And the demultiplexer comes in a multiple variations. That is 1:2 demultiplexers, 4:1 demultiplexer, 1:16 demultiplexer, 1:32 demultiplexer. And this is the 1:2 demultiplexer block diagram. This is the reverse operation of the multiplexer. So that's why we have to draw like this. One is input data line. That's why we have to represent is D0 input enable and only one selective lines and two output lines, that is Y0 and Y1. At a time only one data input will be selected. That's why when it is enable pin is high, then data pin is selected. X means don't care condition. Decoder. A decoder is a combinational circuit. It has n input and to maximum m is equal to 2n outputs. Decoder is identical to a demultiplexer without any data input. It performs the operations of which are exactly opposite to those of an encoder. This is the block diagram. 2:4 line, 2:4 decoder. 2 represented input lines. That's why we have to take the variables A and B. 4 determines the output lines. So we have to written like this: D0 to D3 output lines. We have to consider the LSB to MSB. So lower priority inputs to higher priority inputs. Encoder. Encoder is a combinational circuit which is designed to perform the inverse operation of the decoder. An encoder has n number of input lines and m number of output lines. An encoder produces an m-bit binary code corresponding to the digital input number. The encoder accepts an n-input digital word and converts it to an m-bit another digital word. This is the block diagram of the encoder. N input lines and m output lines. Thank you.